So I'm going to calculate percentile and then thing on that. So you can see 9.9 something is 90 percentile for me, right? So I'll filter my data set based upon this outlier threshold, right? So how to filter it? I'll write df and df height column ig height column will consist, and this is the maximum. If I run this, I'll got only one name called Imran. Height is 14. That if I'm considering heights are, how a person can have height of 14.5 feet? That's the question mark. And of course, outlier percentile. So this value will create problem in my prediction part, in predictive part also. How I can go with the calculation part? I this my median value will be it. My mean value will be it. Every calculation mathematical background will be scattered. I'll go with this plan value 14.5 height, right? So I'll check the mean value are the other have, and of course it 4.5. So less than 5% or 0.05 I'm calling it, and this is 5, right? So again, it allow me to a minimum threshold. This minimum greater than or less than is only one person height 1.2. Again, mark how a person can have 1 point height. Uh, uh, though it is not, it is illogical. Have doves in our society. They can have height, not height. But as of now, I'm not considering that dome class is of a Bona kind of society. So I'm considering this is out of the box for. So I'm going to and from my data logical. I'm going to outliers and the base for outliers for removing. Let's a first round bracket, and inside my df data by this condition, right? First condition, df height threshold. Copy this first parenthesis. Along with this condition, what should should be height should come threshold. Copy this and paste it of threshold, right? So I'm going to consider it greater than minimum and low both are accepted. So I'm going to perform outlier and find 13. 9 is removed, 12 is also 12 is associated with Imran class. Candidates are removed tabular data set, and I have removed this entire data, right? This is the statistic part and small functions, remove outlier from statistic. part in this take for property prices dataset. So now let's explore Bangalore property and it if for dot underscore CSV, and this is Bangalore house property dot CSV, and let me run the code. Okay, I have not coded here. So click on upload button here and go to the correct location, feature engineering statistic, and this is the php.c. We are doing feature engineering for this part, right? Code one more time, reflecting on the screen, and we are going to calculate that part, and we have more columns in our Bangalore property data. So can we check the shape of this property? Yes, we have 13,200 flats in our case system. Really wonderful. And we have location, total square feet, how many bathrooms are there, price, BHK like bedroom, hall, kitchen, price per square feet, given everything on the right hand side, right? So they are going to calculate some descriptive part like have describe for statistic value, and of course how many integer value we have, sorry, numerical value we have 1 2 3 4 5. So of course 1 2 3 4 5 respective 5 quantitative values are including in my describe function statistic. So we have 25th percentile, 15th percentile, these are not the percentage but presenting percentile here. We have maximum value in record column, standard deviation, we have this row, mean that is average, count, how many counts we have. So this is represented by here only, right? So what others features, what kind of other feature engineering we can perform over there? So we are going to explore some samples that are above 99.9 percentile and below 1 percentile rank, right? So this is the range for my exceptional value, right? So let me create one variable, threshold, minimum threshold, and maximum threshold. These are two variables, and let me acquire this df dot, and this is for price per square feet, price per square feet column, the last column, and of course this will be the target column. So they want to check the outlier for this thing. So what we can do, we can give the square brackets or the parenthesis here, and then first we will pass first 1%, right? And then we will pass 99, right? And let me copy the have it. Okay, pass the file, then get the minimum value for this 0.01, right? It's kind of, and for maximum we have right. So what we can do, we can go for the other value, like we can take the div, and with this d dot price square underscore price per square this column must be less than threshold. Values are there. Those are below this threshold. We have so many entries. Okay. So total entries are how many? 13,200. So they are very less in quantity. Like we have very less below 1%. Right? Let me copy this code again for the maximum threshold value above maximum the difficulty here and allow me to how many values are above the threshold value is maximum. Yes. So we have the category. Let's those are not full my range or not falling in. So what I'll do, I'll try to remove the outliers. So the action I am going to remove these outliers. So I create another data frame called it df, and within this df, so from the old one, I'll take the first condition and the second condition with second threshold value and store, right. Let me take this first condition, right. So this is the first condition less than maximum threshold, right. And what should be the max greater than minimum threshold? Then I'll take the df2 or the exception. So when I look at the 13,170 rows, they are not considered one person outlier, right. So it's your choice, your case study, your realistic example, like what is your percentile rank on the basis of the category we are going outlier, right. How we can go for the custom kind of it's our potential challenge, like what kind of implementation, right. So again, like what others methods are have outliers using, right. And it's important times we are asking this why we are using, right, why we are seeking for this outlier detection and remove instant python pandas, right. So how to calculate the g for this we require had already. So at matplot from dot div py dot s, right, 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 dot these are super dot size at a global. I don't have to write size of cart all these. We are going to hide data from kaggle dot and just it just give the set has heights we have removed and well and this where we are can download that data height and this CSV file can, and if you want to go for the disk part you can height and there part height and date I have removed. Now I'm going to import this height and width, and this is called dot, and this is called I dot, right. Time we had already got heights of 5, and their heights are given, and this is outlier we have already had removed, but it should, right. So we have this, and let's have another for the heights and consisting of column. Take this, now we have more, right. Previously we had very, now we have dot 7 or the page for this 10,000 records we have for gender and heights. So first we will create the histogram. Histogram we have function f dot hei, first numerical value, and then I'll take number of bins, can or increase number of bins as per choice. Then I'm get r width. I'll explain r width. I'll call p dot, and this called ig, have height x limit, and I'll lt dot y, and this y limit called count y limit, right. So plt dot show epic star okay, 1 2 5 6 20, 20 bars are here, can have 20 pins. We are Actually we had taken bars for my, let me change this r weight if I'm converting it to point. Can you see width of my bars are now changed? So first parameter inside the hist, first argument is for my numerical data set on which we are going to histogram. So histogram is usually for continuous, right. So this height is continuous category, and this bins, how many number of bins you want to create on the screen, right. You want to create the packets x axis. Now the x label and y label is quite simple, and you just show the entire histogram. Can you see it's creating kind of bell shape? Can you see? It's a more likely we discussed in the previous session. The 95% data will like 68% will about this one, and 95% and then 99.5% it around the value. Can you take that figure out? Right. So that rule, right. So this statistics concept says 68% data set lies around value. You can see from histogram also. This might be more, but in normal distribution, this is 68%. 95% data set rotating around is just on the middle part, right? Ideal conception, not the hypothetical. At 99.7, beyond 0.03%, I'll call it outlier if they exist. If they are not existing, I'll skip that part. Otherwise, I'll call it. I'll have to remove or impute how to kind of purity, right? Now I'm going to plot some bell curve here. So this is from I pi dot sets normal distribution part. This is norm part. Then for this normal distribution pi and then we guilty dot come for my if dot igst hit right column have been r it equal to 8 density, right? And then we will fix label, and for this I'll call ig item, but rn I'll create some render for this dot h height dot minimum value. I'll take the f dot ig value out, arrange for my entire lt dot plot. I'll create plot and part this with dot for respect to rng dot dot is have that value probability, and this of probability range. Take this RNG down the minimum and maximum is 9 and the minimum is 50, right? So this range is getting so many. You can see it's just 0.01 difference in discrete entire value for creating bell curve, and it's a full bell curve around the program entire value. But we are going to take HEIGS value for my right f dot ig standard value. Here we have a standard value. Take this standard value is like, so So what is the mean value here, right? So if you take from this part, this 1 sigma would be plus this sigma part, right? Plus 3.8, actually 6 plus 2 times 3.8, actually 6 plus 3 times 3.4, the standard deviation orientation, right? You check upper limit plus times f dot heig standard deviation, right? So this is upper limit, and of course the lower limit have upper limit, lower limit, and mean minus 3 times it is for left hand side, right? Copy this upper limit, right? So on the right hand side we have, on the left hand side we have 54.82, and on the right hand side 77.9. Beyond these values, lower limit and upper limit, we are going to observe all these values as an outlier. So this is the second method. We are going base on the basis of value, we are going to outlier, right? So here are the outliers that are beyond 3 standard deviation from me on both, right? So what I'll do, I'll just filter my data set based upon these. First, if then first condition and then second condition, right? What's the first condition? First condition, if dot height should be greater than upper limit, and second condition, if dot hig should be less than lower, right, or operator, right? So upper limit, it should be above upper limit, and it should be less than, have, so right. So these are beyond upper limit and lower limit. All these values are outlier form. I want to remove sides, right? So are these outliers, or we are using or operator in order to identify the, right? अब ये जो heights है higher speed 8.4, all these values are outliers, right? So now the part we are outliers and generate new data frame. F and outlier. F, and then first condition we are going to take f dot less than upper, and f dot ig height greater than lower underscore the 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 operator, end operator, or operator, end operator. That are having entire data, all these, right? So for our shape, we have 9,993, right? And what of our origin? 10,000. So how many values we have removed? We have only seven values. 1, 2, 5, 6, 7 out of 10,000 iota of value. We are removing very small part from our data point, right? Have removed 7 outliers out of this, and we get the part, right? Okay. So the next part we have 4 indicates. So like is how many taken away are dead points, and for example standard deviation is fine and value data for that is because it is deviation, right? Can you score for this is 3 because it is deviation away, right? So we have df value column here for column dot is height divided by dot ig dot standard deviation, right? And you can see five, right? These are the records which consist in height, score, and value and these, right? What's the score value, right? This df dot height observation for each records. Df dot height is and divided by denominator of standard deviation per population and respective, right? So right for the if get like these 5 points are on G, right? They're going to get the data point. So this is going to get data points that has G score higher than or lower than minus, right? Another way of saying something is get data point on these. Copy this and paste it here. And if I call it less than minus, I'll get 1, 2, 3, 4, 5, 6, 7. So it's again the 7 values I can remove from my entire sample page, right? It is nothing but the outliers, and this is the other methods to move outliers on the of G. The interview may ask, and so many times it's so like what is the G score? We have studied this G score in the class 9th, class 10th also, class 7th and 8th also, right? Sometimes we are starting at, but what is the role here in the structure data? Can you see here? So we have list of we can detect or we can diagnose the outlier for the help of G, right? So can we have the entire equal part, right? So are just if and first condition if dot ig height, but the height 4 less than minus, and the condition we are going here. I'll take for and we get all the 5 values outliers. Allow me outliers and copy this part here, paste it here, and out, right. This outlier is just paste, and it should be greater than minus or less than, and instead of and operator or operator, all these outliers. And for potential, I need all entire my was originally 9,000 and original of have removed 7 out of this. So is this sufficient for